All right. Let's see. You should be able to hear me, okay? And there we go. Okay, so let's see. Hopefully, all of you should be able to see what I'm doing. All right. Let's go ahead and see who's here in chat. Okay. So, let's see. Can you guys see IntelliJ? Or can y'all? Ingrained habits. Okay. So, what I wanted to do today was start talking about logistics of being a good developer in general. Not just object-oriented, but object-oriented in particular benefits I want to say the most from understanding your build system and being able to have ease of deployment and use and things like that. So you'll see here I have a graph class. I have copied this code exactly from a example. That's why it's somewhat interesting formatting, we'll put it that way. And so you all understand the basics idea of a graph. It's a bunch of nodes, and the nodes have they have vertices, and the vertices can have edges between them. It can be directed or not. It can have weights or not. I will link the actual web page that I found this content off of for you. But what's important is we run this. Oh, and it will give us a depth first search of the graph created by this input. And if you're not familiar with depth first search or breadth first search, that's fine. There are different algorithms for searching a tree. or in this case, a graph. So what I'm not asking you to do is implement graph logic, because that is a complicated topic that starts in data structures, realistically is sort of touched upon again in algorithms, and then if you become a grad student, then you really start actually implementing graphs, and having that be, at least for Vanderbilt, our algorithms instructor was a very graph oriented, so all of our questions were having to do with graphs. So I have cried many a night over graphs, and so I'm not going to do that to you. Instead, what I want to do is use this as a good example of you all implementing and refactoring code. Our second assignment will be based off of this code. Or I'm sorry, second set of assignments. So third and fourth assignment will be based off of this code, refactoring it, making use of it, things like that. So does that make sense to everybody? Like, you're not going to have to understand the deep intricacies of how the algorithm specifically works. So we come down here. Oh, it's just printing out the graph. It's not even doing that first. Well, anyways. But yeah, so that's all. I'll have more examples. Today is more, we're just using this as an example. We're not actually even going to dive deep into the code. But here's a printing of the graph that was inputted here. Does that make sense? All it's saying is vertex 0 has goes to edge 1 with a weight of 2. Vertex 0 goes to vertex 2, you can call them node 2, with a weight of 4. So it's just printing out the graph. Does that make sense to everybody? It's not super complicated. You don't need to know how it's stored. There's key terms in here like adjacency matrix and stuff like that. But I'm not asking you to get that right now. So, okay. What I wanted to show you is, this is a project that I started by coming up here and creating a new project. And we didn't really talk about this much over here, but Java projects by themselves aren't the most useful thing, because they're actually difficult to build in practice. So, Ant was the, I think, original, and may still be the officially approved build script that was used to build Java programs. Then, I want to say, Maven came out. And Maven is just think of it at the broadest, simplest oversimplification. It's a database, it's a build script system to enable you to access libraries from a database online, or potentially locally. And what this does is this avoids what was used to be called dependency hell. So you would have to go and grab, like, let's say here, .NET data binder :data.app. Oh, okay. which exact version of that do I need? Oh, okay. I need this library. What version of that do I need? And you have to go and get the actual class files or jar files to import them into your project, generally jar file. Import that into your project, then you could build your program. And you can imagine, look at this giant list of things. If you had to import half of them, which is not that many for a large program, you would, it would just be a lot of tedious, possibly error-prone work to make your system build. Does that make sense? It's sort of a brief history of the concepts of how Java development was created. I will actually go ahead and load or copy some videos. They're a couple hours long, but I do highly recommend you watch them. It's when Gradle was introduced to Android Studio, or Android. And it helps explain and talk about this. And when I talk about Gradle, it's a programming language in and of itself, built on top of, or built in the Groovy, or it's a domain-specific language for essentially building things. So software, written in Groovy. What is Groovy, you might ask? Groovy is actually a really interesting programming language that is both a command line and I believe interpreted, maybe compiled. Honestly, I forget all the nuance of where that language is moved to, but it's a command line version of Java, essentially. If you can think of it that way. So you all had Python in 1595, I believe is the class number. Or if you didn't, you had 2610, correct? Okay. So even if you took 2610, you still learned the Linux commands, right? Basic bash commands. Okay. Okay. So, Groovy is a really nice language because it's dynamic, and so you can change things at runtime, and it's interpreted based on the current situation of the system. And what I did was I made a project based off of Gradle, or a Java project, and honestly I forget. I'm so in the world of Android for so long now, I forget how the best way of doing this. But regardless, here's a Java project, but you'll notice it has a build.gradle and some other things in here. I'll make more detailed videos explaining all of this. I'm not asking you to, from scratch, create Gradle projects, but it probably will be a good skill set for you to have. That way you can create your own test projects and or develop on your own. So that's why I didn't really dive deep into how I made this. But what's important is you see how it defines things in these code sections, we'll call them that. So here's a list of the repositories. Here is the dependencies of what it's using. And you'll notice it's highlighted, meaning I can upgrade. So 570 to 581, 570 to 581. I just upgraded the dependencies that my application will use for running. And that's really simple. Now, when you're in a real work environment, generally you dedicate some individual person to edit these and test that your entire system builds, or you do it automatically and then have somebody supervise it. But you can do custom tasks like this, and we'll get back to this. This is really nice, and it'll save you a lot of effort. So, just like before, we come up here, we press the play, and the application will run. But you'll notice there's some tasks that ran before, and it makes sense. Java compile, process resources. There are no resources in this application, and the classes are up to date. It ran main.main, and here's our output. That's overall, conceptually, at this point, we're at the same place we were before. But there's this Gradle and Maven, and there's all this stuff working in the background. And I just sort of want to touch upon those. I'm not going to ask you questions about it specifically, definitely not right now for the first exam. And just to give you some background of where we're going with this. Now, you'll remember notice there's a build directory in here, and we come in here and there'll be the actual Java class files, which we don't want to actually share when we submit our assignments. But before I told you it's okay, we'll just deal with it. Now, what I've done, and I'll show you how to do this, and this is how you'll, from now on, make the zip files that you'll submit for your assignments. You'll come over here, you'll click on the Gradle window, come down to Other, and click on Zip. Notice, there we go, sorry. You'll now have a zip folder inside distributions, build, and then distributions. We open this, and it only contains your source code. Yeah, there's other folders in here, like resources, but they're empty, so you can just ignore them. It'll only contain your source code and or your test code. Does that make sense? It just saves you hassle, and you can auto find it. I'll probably update this to copy the from the that folder up to the main root folder for you. But you'll now have a nice, easy way of creating the zip file with the smallest possible size, and you won't have to worry about what files to submit. Because a lot of you submitted the Java file directly, or the code directly, despite I said I wanted it uploaded as a zip, but I didn't take off for the first two assignments because of that. So, but moving forward, we will. It might to the point where you won't get graded if it's submitted wrong, improperly. So, okay, there's how you make the zip file. What happens if I do it again? It just overwrites that zip file. So, that's nice. I had talked about clean. Oops. Explore. There we go. I had talked about cleaning the project. Double click that, and you'll notice the build directory goes away. So this is the clean version of your project. why that is important is for archiving your source code. We will talk about how you'll manage source code through using Git later in the class, in the course, not today though. There we go. The other big thing is down here under verification, we have test. It ran, and it came over here, and it says tests, and you'll see green check marks. Does anybody know what I did? Probably not, but some of you might have looked into it. I had mentioned it previously in the course. Somebody's typing, so sorry for that. That checks, and the IDE gives a green check to say the program is good. That is technically sort of in the direction of being correct, but what it means is that I'm coming down here and I'm running what's called a unit test. This is what we'll spend the next couple of classes talking about, is how to write unit tests and how to design your code to be testable. So I don't want to dive too deep into that right now. I do want to just demonstrate that it's pretty straightforward. You can see here there's an edge. I'm creating source, destination, and wait, 1, 2, 3. Expected, 1, 2, 3. Source, destination, wait. Run it, and it is correct. Now, let's just change this value. Expected 1. It's not what it's expected. Run it again, and it'll tell us we failed that test. So, just think about this. What does this enable us to do? This enables us to test small snippets of our code and then have lots of tests, because we could do this. This is silly. You wouldn't do this, but we now passed test instructor 2, but we failed the first one. So phrase this. Excuse me. Who or can you see why this is important? Let me put it that way. We have talked about in the class how it's generally the best idea to subdivide your problem into as many sub problems as possible, and have individual classes or packages or methods that are associated with parts of the subproblem. And so you're trying to subdivide the problem as much as possible. Now, when you think about that, here's a test for a subdivision. You can, once all your subdivisions work, shouldn't the application work? Theoretically? Well, that's a good question. I know, I asked it. No. whether or not your application is well tested depends upon a couple of things. Is your application designed to be testable? There are ways of making code that's not easily testable. And do you actually have all the code that tests all the different parts of your application or significant parts of it? Notice I have a graph class here. There's a lot of code in here. I'm not testing any of that. There's no code here. We click in here and we go, well, huh, interesting. Sorry, what I was looking for is Android Studio has an option. Maybe it's the way I have things configured, but it'll allow you to right click and create a test. Regardless. So you can create tests for all the different classes, and then for each class you go ahead and create individual test cases for each of the methods, and then each of the methods, if you change something in one method, does it change how another method works? So for simplest example of that is a getter and setter. If I call a getter and I get a 5 returned, or a string that says hello world, okay. Then I put a setter and I say goodbye program or 4 or something like that. When I call the getter again, if there should be assigning to the same field or fields, individual instances of fields, or individual fields, you should get back the new updated information. So if I have an integer that I'm storing, I'm getting it back as a 5. I say set that integer to 7. If I say give me the integer back, it should be 7, not 5. If it doesn't actually set the value when you tell it to save the value, then there's a problem. So what you do is you create a test where you set the value and then you get the value back and you make sure that they work. And that's exactly what's here. I'm setting 1, 2, and 3, and I'm testing that 1, 2, and 3 are returned to me. Does that make sense? It's very straightforward. I'm just trying to cover high-level concepts today, not in detail specifics. We will spend lots of days diving deeper into these topics. So I want to make sure that I'm giving about half the class today to answer any questions that anybody has. Make it sort of an open study hall type Q&A session. So this weekend I'll go ahead and finish grading basically everybody that submitted the assignments 1 and 2. They'll get almost, or they'll get full credit or almost full credit. So I really just wanted to give you an opportunity to see the type of assignments that I'll be providing and give you an understanding of how I'm going to evaluate them. It's not perfect in that these were mainly for self-evaluation and things like that, but just give you an idea. So we will end the actual instructional part here. I would recommend you stick around and watch or listen to any of the QA if anybody has any questions. You will be surprised how informative those types of seeing what others in your course are asking might elucidate or spark a question you didn't realize you had. So, does anybody have any questions? Are there other ways to use these test functions? Oh, there's an unbelievable number of ways to use them. So, oh yeah, lots of ways of using them. Android has ways of testing the UI, faking or automating a click on a button, testing whether a text view, which is what they call the views that show text, original naming, I know, making sure, getting the text from a text view, checking that it's been updated to a certain value. There's an unbelievable number of ways you can do things like this. There's what's called mocking data, but we will get into that later in the course of how you design classes for testing. Any other questions? Remember, the exam will be next week. It will cover chapters 1 to 6 and the 4 design patterns. Adapter, bridge, factory, and abstract factory. No. My mistake. I'm sorry. Adapter, builder, factory, and abstract factory. Bridge, we're not covering that. No questions? The other people can type. I do give you permission. I don't mind one person talking a lot, but the more you talk, the better it is. 10% of your grade is class participation. Yeah, we will dive deep into testing. Here's a good example. The assignment's starting soon. What I'll do is I will give you a subset of the unit tests, and I will tell you to write the code that makes the unit tests pass, and then I will, once you get all of those working and you think you've caught all the other edge cases I didn't show you tests for, then you'll submit it, and then I will grade with the full set of unit tests, and that will be how you'll get your score, after I also check code structure, formatting, things like that. So that's one way. If you look at the courses I've done online through Coursera, that's how all of them have extensive unit testing built into them for grading. And it's actually a excellent educational methodology, because what it does is it teaches you as the learner how once you think you have a good solution, if there's still problems that are obvious, then it will inform you as such. It's similar to how HackerRank or LeetCode, they give you test cases. They're using unit testing. Maybe not JUnit the way I'm showing you here, but same general concept. Okay. I won't keep you here the entire class if nobody has any questions. I really did just intend to leave that second half of this class for Q&A. So, we will go ahead and end the stream here. And if anybody has individual questions they'd like to ask, they can message me. I'll get back to you as soon as I can. And then we'll go ahead and end here, I guess, for the stream portion of the class. Make sure you've read and studied the chapters. I am here to help you if you have questions. If something doesn't make sense, feel free to ask me. Like, I'm not telling you you're on your own on these questions. So, I want to make sure that's clear. Next week, the exam. Let's see. What's the best way to study for the exam? The best way to study for the exam. Have read the book. Ideally 2+ times. And then practice programming in Java. Go through and follow along in the book and make sure you know how to do every section that it talks about. Make sure you know how to write an email. Make sure you know how switch statement switch statement works. Make sure you know how to do standard input and output. Make sure you know for loops, while loops. Knowing the basics of encapsulation, information hiding, interfaces. Understanding variable types. Understanding the like in the quiz, we talked about classes, instance variable, primitive types versus reference types. So what's a class? What is an array? Things like that. Know the basics of UML. Valid promotions. I'm not sure what that has to do with anything. Oh, promotions of types, of variable types. Yes, that is correct. Understanding how constructors work. Understanding getters and setters. Yeah. If then else statements, understanding how those work, understanding nesting them, the conditional operator, so the use of the what do you call it? Question mark and a colon. That's not something I particularly like to use often, but it is extremely useful sometimes. So I think it's important to know. Counter iteration and sentinel iteration. That's important. Basically, just go through the book, and every section is basically important. That's a little bit of a cop-out, I understand, but do while iteration. Strings and switch statements. Breaks and continues, understand how those work. And understand the logical operators. Know how to write methods and how parameters and method types and things of that nature work. Understand overloading. I mentioned enums already. Static methods and static fields. It's only 6 chapters. I know that sounds like a lot, but it's really not. This book is like 15, 20 chapters. 25, 28 chapters. So, we're just covering the first 6. And I'm going to figure out exactly how the delivery mechanism of the exam will be. It will be, let me rephrase that, delivery conditions. The mechanism will be through Blackboard, just like you had through the quizzes. I will figure out how to best provide flexibility for the delivery, and I'll give specifics of that on Tuesday. So, or before on my email also, how that will work out. I'm debating whether or not to give you 2 hours during Wednesday to Friday, any 2 hours that you want to use to submit or complete the exam. There's some logistical issues with that. I don't want to get into it right now, but that's one thing I'm considering. So that way you understand where I'm coming from. I'm just trying to figure out how best to actually oh, there is a tornado warning in this area right now. So I'm going to go ahead and recommend that I'm going to end here. And I would recommend that you also go ahead and take shelter. So, we'll go ahead and end the stream now. I will have my device with me, so if you want to ask questions, you're free to. But hopefully you all stay safe, and we will go from there. All right.